In this video, we are going to take some of the graph theory that we learned abstractly without context, and we're going to apply it to a really cool game called Ticket to Ride. So if you're not familiar with that game, do please check out the tabletop video that explains how that game is played and then shows an example of how you do it, because that will really help us out. And make sure that you're familiar with the graph theory concepts before we begin. But I'm going to use Mathematica to handle this because Mathematica is really good at doing all sorts of graph theoretical concepts. So I'm going to post this Mathematica document online for you to interact with later, but I thought I'd walk you through it in just a couple of videos to show how to do some of these important things. So as always in Mathematica, you do a silly computation first, so it can load libraries in the background. It goes very quickly most of the time. What I've done here is I have created an Excel document that has the adjacency matrix for the Ticket to Ride game board. Now, it was just easiest for me to type that into a spreadsheet, but all of the graph theory machinery that I want is hidden within Mathematica. So Mathematica does have a command for importing CSV files, just like any good programming language. So I wanted to show you how I got that. Now, if I go to my computer, I want to find this CSV file where I created the Ticket to Ride adjacency matrix. So let me go show you what that is. I'm going to go to my documents. I have a folder for mathematical computing, and inside that folder I have this lovely CSV file for Ticket to Ride. And I can open it up and show you what it looks like. Cities are labeled down the rows and columns, and I've got those zeros and ones. I want to import this document into Mathematica, and so what I'm going to need to put into Mathematica is the file path to access this document, and I can find that by finding the document I want, right-clicking with my mouse, going down to Properties, and then right here is this location. So I can highlight that location and copy it, get out of here, and I would come back into Mathematica, paste it, and you can see that what I have right here is very similar to what I have right here. So it's different in a couple of ways that I wanted to point out to you. First of all, this is the path to the document. If I want to actually include the document, I need to add an extra backslash there and then say, well, the name of the file was Ticket to Ride.csv. So I need to add that in order to make it match here. And then you'll notice another annoying little technicality. Here I have a single backslash, and inside this document I have double backslashes. Now, this is because most programming languages use the backslash to have some sort of special meaning to the programming language. That is true of Mathematica as well. So if you want to tell Mathematica, don't use that backslash the way that your language wants to use that backslash, use it how I want you to use it, just as that backslash, then you can put another backslash in front of it. So instead of a single backslash at each one of these things, I have a double backslash, and a lot of programming languages will also allow you to switch those to a forward slash, and that would have the same meaning. So last but not least, that file path is what's called a string data type, and so we need to encase it in these little quotation marks in order to use the import function. But after making those couple little changes, I hit import, and Mathematica reads in the contents of this CSV file and stores them in this TTR object. So if I want to see the TTR object, I just say TTR and hit enter and say, show me, Mathematica, what do you think is TTR? And it shows me the exact contents of that CSV file. So the last thing we're going to do in this video is we're going to format this, because what I really want to do is strip away all of the city names and save them for a little bit later. And I just want to keep the adjacency matrix for Mathematica to hold on to, because that's where all the computations are going to come from. The city names are a nicety for me, but they're going to actually just bog down the computer. So the first thing I'm going to do is get rid of this entire first row, which is all city names, those coming from the top of that CSV file. Now, Mathematica, so let's store them for later because we do want them. So let's store them into a list called city names, and where I'm getting them from is from the first row of that Ticket to Ride element. See what it shows me there. But remember in that CSV file that I kind of had a blank cell right at the beginning to separate the rows from the columns. And so I have this blank right here with just a comma at it. It happens very frequently that the first element in the list is somehow bogus and we don't want to keep it, but we want to keep everything else. And Mathematica has a command just for that. And it's called REST. R-E-S-T is a Mathematica command. And it says, here's a list. Let's take everything that comes after the first position and give me all of that as the output. So if I just type in REST of city names, it shows me what I actually want for city names, which is getting rid of that space with the comma. However, if I now ask it for city names, it shows it to me with the comma again. So all Mathematica is doing when I call the REST of city names command is it's showing me what that would look like. It's not actually making a change to the list city names. So if I want that change to be permanent, which I do, then I need to take city names, what's currently in it, and replace it with the output of the REST of city names command. And when I do that, the change of omitting that first comma becomes permanent. All right. So at the moment, if I ask Mathematica to show me Ticket to Ride now, it's going to show me exactly what I wanted before. So one thing I want to do is use that REST command on TTR in order to get rid of the first row of TTR. So let's take that step. TTR is equal to REST of TTR. And then we'll ask it to show us Ticket to Ride. And look, it's gotten rid of that first row, which is great. But the next thing we want to do is use that REST command all over again on every single row that remains in the TTR object. So we want to get rid of all of these first entries of the rows in the adjacency matrix so that all we're left with are numerical values, zeros and ones. So what we want to do is starting at 1, going up to the length of TTR, or the number of rows, incrementing by 1 at each iteration of the for loop. What we want to do is we want to take the current row, which would be TTR at I, and we want to replace it with the REST command applied to TTR at I. So take the row, apply the REST command to it so it drops the city name and keeps only the numerical data, and then make that change permanent by replacing the row that's currently there with the output of the REST command applied to that row. And when I make that change and ask Mathematica to show me TTR, now we're in business.